Hello everyone, welcome back to Bimbel Bilcen. In this video, we are going to learn about quadratics part 1. In this video, we are going to learn how to do completing the square. Completing the square is a method for us to solve quadratic equation or a method to find the minimum value or the maximum value of quadratic function. So, let us recall how to solve quadratic equation. Now, if you have quadratic equation, we think about this method, factorization. If you still remember factorization, we try to find two integer numbers and then it matches with our quadratic equation. So, there's a problem here. Sometimes we cannot find the integer solution. So, for example, we have x squared plus 6x minus 1. In factorization method, this is x squared, so it's x and x. And then our goal is to find two integer numbers. When we multiply them, we get minus 1. But when we add them, we get 6. But the problem is we cannot find those two numbers, those two integer numbers. So we cannot do factorization here. So what should we do? In this video, we are going to learn about completing the square method, guys. So let's take a look at this method. Why is it called completing a square? So here I have visual proof for you to understand what is completing a square and how does it work. So our goal is we want to solve this quadratic equation x squared plus 6x minus 1 equals to 0. How to do completing a square? First, let's focus on these two terms first, x squared and 6x. Yeah, let's ignore the minus 1 for now. Now, why is it called completing a square? Because we are going to construct square from these two terms. Let's think about an area. Yeah, so x squared, we can construct a square with sides x and x over here. And we know that the area is x squared. 6x, we cannot construct a square because we have 6 and x, but we can construct a rectangle with length x and with 6. So the area is 6x. Now we want to combine them, x squared plus 6x, and we want to construct the square. But how do we construct the square? Here's the method. I divide this rectangle into two, becomes 3x and 3x. The area becomes 3x and 3x. Now, I move one of the rectangle vertically to the right side of our square. So I move it like this, and it matches with this side because the sides, this is x and this is x. So it matches with the square. And then I put the other rectangles horizontally like this. Now, as you can see, guys, here we have almost a square. But the problem here is we have a missing square. That's why our method is called completing a square. We have a square, but there's like a small missing square that we need to complete. Now, let's take a look at our equation here. Here we have x squared plus 6x. Let's focus on that first. X squared plus 6x. This is basically this one, right? We have x squared, the first area, and the second area is 6x. Now, these two area basically equals to this. Now, as you can see here, we have a square with sides x plus 3. So we have x plus 3 times x plus 3. So the area will be this one. The area, this one, will be equals to this one, which is x plus 3 squared. But the problem here is, it's not complete. we have a missing square over here with sides 3 times 3. So that means we have to subtract our area with 3 square, which is equals to 9, because we have a missing square there. So this is called completing the square method. We're trying to make a completed square form. So this is called completed square form. And this is very useful because we can use this to solve quadratic equation. So let's go back to our original equation. We have x squared plus 6x minus 1 equals to 0. And we know that this one will be equals to x plus 3 squared minus 3 squared. And then we have extra minus 1 over there equals to 0. So we can solve this. We get x plus 3 squared equals to 10. Now from here, we can square both sides and we get x plus 3 equals to plus minus square root of 10. So we have x equals to minus 3 plus minus square root of 10. Now, this is how we do completing a square. But when we try to solve a problem, obviously, we will not drawing all of this to find the completed square form. What you need to do is to see the pattern. So how do we complete the square for this one, x squared plus 6x? If you look at the pattern, we divide the 6x into 2, becomes 3x and 3x. So if you look at the pattern here, this 3 comes from this value and then divide by 2, right? Because we divide the rectangles. And then this missing squares is just basically this number being squared. Because this is 3, and this 3 will become the missing square. So we will have some step on how to do completing a square. So let us jump into the first question. Okay, now let's take a look on this example. This is taken from past paper 2022. So we have two functions, f and g are both defined for x element real numbers and are given by this one. Express fx in the form x minus a squared plus b. Now, this is a step on how to do completing the square. The first one, we're gonna take out x squared coefficient. For now, let's ignore that step first because for fx, the coefficient is 1, so there's no problem there. The second step, half the b. What is the b? In the quadratic expression, b is basically coefficient of x. So for fx, this is the b, minus 4. And then the third step, we square the b to complete the square, the missing squares. So let's do the step. So we have fx equals to x squared minus 4x plus 9. Okay. And then how to do complete the square? First, we have the complete square, and then minus we have the missing square. For the complete square, we have x squared minus 4x. So we focus on these two, like in the visual proof. So x squared minus 4x. So we have x over here, and then we have the b. The b in this case is minus 4. So half the b will become minus 2. So we put the half the b over here and half the b over here. So that's how you do completing the square. So, oh, and then we have plus 9 over here, don't forget. So we have x squared, sorry, x minus 2 squared minus 4 plus 9. So we will have x minus 2 squared plus 5. So this is the result. Now, the problem will become harder if you have the coefficient of x squared is not 1, but other numbers, for example, 2. So we need to do the first step, which is take out the x squared coefficient. Now, we want to express gx in the form 2 times x plus c squared plus d. Keep in mind that Keep in mind that 2 is basically factorized, right? It's taken out from all of these terms. So gx, let's take a look at the problem over here. 2x squared plus 4x plus 12. Now, we take out the x squared coefficient. So we take out the 2 from all the terms. So we have x squared plus 2x plus 6. And then we just do complement square as usual. So we focus on x squared and 2x, the first two terms. And then we put the complete square minus the missing square plus 6. So we put x and then we have the b. The b is the x coefficient. So we have plus 1 and then we put plus 1 over here. And then we have 2 times x plus 1 square plus 5. So this is the result. So easy, right? So let's move on to the next question. The next question taken out from past paper 2024. So let's take a look at this question. Express 3x squared minus 12x plus 14 in the form 3 times x plus a squared plus b. Now, this one is a little bit different from the previous one because if you look at the previous one, we take out the 2 from all the terms. But this one, we just take out the 3 from the completed square form. So how to do this question? Let's do the same step. The first step is we take out the x squared coefficient, which is 3. But now, okay, let's write down the question first. But now, we only take out the 3 from the first two terms and leave the 14 because we do not take out 3 from the 14 from this expression. So we take out the 3, so it becomes 3 times x squared minus 4x plus 14. And we do the completing square as usual. So we put big brackets to represent the two terms. And then we put the completed square minus missing square, close bracket to represent the two terms. And we have plus 14 outside. So we put x, and then the b is minus 4. We divide by 2, becomes minus 2, and minus 2 over here. So we have 3 times x minus 2 squared minus 4 plus 14. Now, and then we do expansion a little bit. 3 times x minus 2 squared minus 12 plus 14. So we will have 3 times x minus 2 squared plus 2. So this is the answer. Next question. Another question here. The function f is defined by fx equals to 3 plus 6x minus 2x squared. Express fx in the form a minus b times x minus c squared, where a, b, c are constant, and state the range of f. In this video, we are not going to discuss about the range of f for now. We're going to discuss that in the next video. But for now, let's focus on how to do complement square first. So, what is the difference between this question and the previous one? For this question, the x squared coefficient is negative. So it's a little bit more complicated, but it's not that hard. So let's take a look at this. We have x equals to 3 plus 6x minus 2x squared. Yeah, like with this question, yeah, the b or minus b is taken out from the complex square only. This one is not. So we only take out the minus 2 from the first two terms. Yeah, so we have 3, and then we take out the minus 2. Minus 2 in the bracket, we have the first term here, which is x squared, and then we take out minus 2 from here, becomes minus 3x. From here, as usual, we do completing the square. So we put the completed square and then the missing square. Now for this one, we have minus 3. When we divide by 2, become fraction, and it's okay. So we have x minus 3 over 2 minus, okay, it's not enough. We have minus 3 over 2 squared. From here, we just need to do a little bit algebra. So we have x minus 3 over 2 squared minus 9 over 4. And then we expand a little bit like before. We have this one. And minus 2 times minus 9 over 4 becomes plus 9 over 2. And then we have 3 plus 9 over 2. We can change 3 into 6 over 2. So we have 15 over 2 minus 2 times x minus 3 over 2 squared. So this is the complex square form. Let's move on to the last question. In the last question, this is a little bit different. If you look at the pattern here, we do not take out the coefficient. So we have 4x squared over here, but there is no 4 outside. But instead, we have 2x inside. So what should we do here? Now, we're going to do the same step like before. The first step is we take out the x squared coefficient. Yeah. So we take out the 4 from the first two terms, becomes 4 times x squared minus 3x plus 13. And then we do completing square. This is completed square minus the missing square plus 13. So this is x, and we divide the b by 2, becomes minus 3 over 2, and we put the b over here too. And then we do the algebra. Minus, this is 9 over 4 plus 13. And we expand, becomes 4 times x minus 3 over 2 square minus 9 plus 13. Now, the thing is, we don't have 4 outside over here, but instead we have 2 inside, 2x. This is x. So how do we change it into that form? So 4, basically we can write it down as 2 squared. Yeah. And we have x minus 3 over 2 squared. And then we have this one is plus 4. And then we do indices rules. So if you have a squared b squared, it's basically equals to a times b squared. So we combine the square. So we have 2 squared x minus 3 over 2. It becomes, we multiply the 2 with this. So it becomes 2x minus 3 square plus 4. So this is how we do completing the square for this case. Thank you for listening in this video. I hope that you enjoyed this video and can help you to solve completing the square problem. Goodbye.